Hello, my name is Alexander Ziegler. I'm from Siemens and I'm the chair of the OPCUA and subgroup. Today I'm telling you about the cooperation of the 5G ACIA with the OPC Foundation, and I will have some words on the technical integration of 5G with time-sensitive networking in OPCUA. I will start my presentation with a short look on the 5G ACIA. I will talk about the current collaboration activities with OPC Foundation. After that, we will dive a little bit into the technical aspects of the integration of OPCUA with 5G, talking about transport protocol mappings, QS configuration mechanisms, and we will have an outlook on further 5G integration topics. So let's have a look on the major objectives of 5G ACIA. It was founded 3 years ago by the ZVEI as a platform for the OT industry and the ICT industry to exchange the requirements and use cases for industrial applications running on top of a 5G system. The working group of the 5G ACIA are collecting requirements from the OT industry. They have a look on the 5G architecture and are talking about gaps and additional needs from the OT industry. And they analyze how to make 5G robust enough for industrial IoT applications. They do promotion worldwide for industrial 5G and their applications, but they do not create standards themselves. Instead, they use the use cases and requirements to create white papers and technical reports, and will then drive them and contribute them into the 3GPP standardization work. There already have been cooperation activities between OPC Foundation and the 5G ACIA. The first joint workshop with the 5G ACIA Working Group 3, which is the Architecture and Technology Working Group, and our OPCUA Working Group happened in September 2020, where we exchanged general system architecture information. And after that, in April 2021, first memorandum of understanding was signed between the two partners, and it was presented at the Hanover Fair 2021. We have OPCUA members participating in the work item 51, which is actually the initiating party of our cooperation. And this work item 51 is led by Julianne from Huawei, and they aim to create a technical report on the integration of OPCUA with a 5G system. We already received a first list of technical questions from this working group to our OPCUA members, which had the time to give a first feedback on them. But we plan to have a deeper dive with the OPCUA FX members as well, as I think we get more information about the OT related requirements. Further steps for collaborations are currently in discussion, so there may be a follow-up workshop. We also talk about possible joint working group, and 5G ACIA and OPC offices for that are clarifying the legal aspects for further information exchange for drafts and other white papers. In my short presentation today, I'm not able to cover all the aspects of a 5G system. Instead, let me focus on the 5G communication aspects which provide QS for OT applications. In this overview here, we can see different areas and different application scenarios which are covered by OPCUA, and some of them, if not most of them, are relying on some sort of quality of service. So we have in the cloud area, we have the need for reliable streaming of data and events. In the area of controller to controller communication and controller to field device, we need cyclic process data exchange, mostly jitter-free and with low latencies. And if it comes to mobile robots or AGVs running through your shop floor, then 5G ultra reliable low latency communications may be needed for that. So let me now dive into the technical details of 5G in combination with QoS and OPCUA. On this slide, I will give you an overview of the configurable application QoS requirements modeled in OPCUA. So there is, of course, best effort, which doesn't need any specific configuration to be used by a publisher or subscriber. If you need to use priority-based QoS, which is using so-called priority labels, then you need to select one out of them, or out of a given set of priority labels. For example, there may be urgent, middle, or low, and those priority labels give a hint to the network stack how to prioritize those data flows among each other. And the concrete mapping depends on the underlying transport protocol mapping of the data flow. So for example, if you use IP mapping, then the DSCP flag inside your IP frame will be used to mark that frame either as urgent, middle, or low with a concrete DCP value. If you use Ethernet-based communication, then the PCP parameter in your Ethernet frame will be marked accordingly. If you use guaranteed QoS, then you are able to either use guaranteed bandwidth or request for guaranteed bandwidth, or you can request for concrete bounded latency, or you may use a deadline model which requires the endpoints to be synchronized among each other. This, of course, needs signaling of those requirements to the network, and this needs allocation of the network for the requested resources. And these requirements then need to be mapped either to a DetNet flow, which is currently not in focus of the OPCUA working groups yet, but currently we are focusing on the mapping on TSN streams and the related control mechanisms. There are additional aspects of QoS like availability, reliability. Those aspects will gain more importance, of course, if it comes to wireless communication. And they may be mapped on DetNet service protection mechanisms or TSN 802.1 CB mechanisms, which are also called sometimes seamless redundancy. The question now is, how will those mechanisms be used inside a 5G system? A 5G system works on the base of so-called PDU sessions. And those PDU sessions contain so-called QoS flows. And these QoS flows may either use layer 3 or pure layer 2 connectivity. So you can have a pure IP layer in your PDU session, or you may use a raw Ethernet connection in your PDU session. And that means for the mapping of priority-based QoS, we may use layer 3 or layer 2 PDU sessions in a native 5G way. Native means that we do not have any additional TSN specific aspects also given by a 5G system. A 5G TSN bridge will be used, for example, to create a logical TSN bridge for a pure TSN stream needed for guaranteed QoS on a layer 2 base. On top of that, you could also build a DetNet flow, or another option, if you do not need a TSN stream underneath, you can map your DetNet flow directly on a layer 3 PDU session. This is also possible because 5G already provides you some sort of QoS in the native 5G scenarios, even without a 5G TSN bridge underneath. And as I said before, the availability, reliability, and the mappings for those QoS aspects need more investigation. So how are the QoS requirements and their related mappings integrated in our OPCUA layered stack architecture? For example, if you have a UDP-based publisher, then you can use a direct mapping from PubSub to a layer 3 IP-based UDP layer using either diffserv, if you are happy with priority-based communication, or either use DetNet for deterministic guarantees. You also can choose a direct raw Ethernet mapping, either in combination with TSN or not. And this also applies for the 5G integration. So 5G, as I mentioned before, has at least two flavors for PDU sessions. This is the layer 3 PDU session and the mentioned Ethernet-based PDU session, which can also be used in combination with TSN or not. And the same applies for the future Wi-Fi 6 and 7, where we expect also a TSN-like behavior. So in future, we will provide those mappings as well. Not to forget is the IEC IEEE 6802 TSN AI profile, which selects out of the multitude of TSN features a certain profile to provide the base for a converged TSN network, and also 3GPP, or the logical TSN bridge, is expected to fulfill the requirements of the AI profile, but discussions are still going on that. What are the different deployment scenarios we expect for OPCUA with QoS? So there may be multiple hosts running on a mobile robot. Some of them may need to be connected to a host far away in a behind industrial LAN, and this LAN again is connected via a 5G industrial network with this mobile robot. There may be mobile to mobile communication scenarios, and there may be data flows even running through an industrial WLAN connection. They may be IP based, or of course, if you leave out the IP layer, they may be raw Ethernet based connections. And for all of those, we need a way to easily establish an end-to-end QoS over different of a multitude of different network segments, which may differ in their technology. Now let's have a look on the TSN aspects of a 5G system. If end devices would use a layer 2 connection based on TSN, a 5G system builds a form of a logical 5G TSN switch, which then will be integrated like a regular TSN switch. So it's the whole 5G system then will show up as a single bridge inside the data flow between two end devices. Let's have a look on the general configuration of OPCUA with TSN before we come to the 5G specific details. So you may know that OPCUA supports two configuration models. On the one hand, you have the distributed configuration based on stream reservation protocols running inside the end devices and running on top of the TSN bridges. On the other hand, you have a fully centralized configuration approach where the intelligence of the TSN configuration is centralized in a CNC, a central network controller. And this central network controller is controlled again by a COC, which is collecting the QoS requirements from the related publishers and subscribers. So how would a 5G system fit into the different configuration models? As we have seen before, a 5G system can be hidden behind a logical 5G TSN bridge. And this TSN bridge would appear in both of our models. The difference between the integrations are that on the left-hand side, the logical 5G TSN bridge would need to integrate or talk the stream reservation protocol with the neighbored bridges and end devices. On the right-hand side, the logical 5G TSN bridge needs to support the configuration protocol used by the CNC. If you need more scalability, or if you need to run your data flows over a heterogeneous industrial network with different network technologies, then DetNet seems to be the technology of choice. As mentioned in a slide before, a 5G system may provide different ways to establish a DetNet flow, either on a layer 3 or layer 2 PDU session with or without TSN mechanisms. The standardization of data plane mechanisms in DetNet seems to be quite mature, but the controller plane mechanisms and protocols still need work, especially when it comes to network interfacing, which is something really necessary, in my opinion, for heterogeneous industrial networks. Typically, industrial networks are separated in multiple administration domains, such as a machine builder domain, an industrial campus network domain, or an industrial data center domain. And all of those administration domains need to be connected. And the QoS flows may run through all those network segments. And for this and for the ease of integration, a network-to-network interfacing with QoS signaling is really crucial to make this system running easily. I only covered a small set of aspects discussed in the 5G ACIA when it comes to OPCUA integration. There are more aspects like the network exposure function of a 5G system, which may be used for network monitoring of a 5G system, or the application orchestration on top of a 5G system. There are other interesting ongoing work items in the 5G ACIA. Let me show you some of the working group 3, which is the architecture working group. As mentioned, there is the integration of OPCUA with 5G, of course. Then there are discussions and work items covering the 5G industrial device architecture. Moreover, we have a work item talking about 5G QoS for industrial automation. And we have a working group covering the analysis of 5G capabilities for industrial IoT. Other topics like 5G positioning may be of interest from an industrial application point of view. Finally, let me summarize my presentation. I see 5G ACIA as the right forum for OT players to learn about industrial 5G technology and to place their requirements. The OPCUA architecture is actually designed to integrate different deterministic communication technologies, such as 5G. Integration of 5G with OPCUA should be as smooth as possible by keeping a clean layering, using well-defined interfaces and network protocols, and following the TSN AI profile. To bring both technologies together, we encourage the OPC members to participate in the discussion of the 5G ACIA working groups, and of course, vice versa. Thank you for your attention.